Okay, so thanks for your attention, everyone. My name is Si-Yuan, and I'm here representing MobLab, but I did my PhD in econ in 2018 with my advisor, Professor Michael McBride from UCI. And so here to talk about this project that we did, and it's studying small versus large group effects, and basically other findings from the key headline of it being a 600 plus person in-person experiment. And I'll go ahead and elaborate on why I don't necessarily call it a laboratory experiment, but it falls somewhere in the range between what I would say is a totally controlled laboratory experiment and a fully online experiment. And so my collaborators include Po from Caltech, Dongwu also from MobLab, John Duffy from UCI, and Zhu from Xiamen University. Okay, so just a little bit about MobLab. Many of you may have already heard of us, but we're basically a platform that does online experimental economics games for teaching economics in the classroom. And so to go over it briefly, we basically have this extensive game library built out of over 60 games, including some classic games such as Dictator, Ultimatum, Deep Double Auction, and other stuff like that. And another key important feature which enabled us to do this project is that we have all of these games online and available for all of the different sort of mobile device ecosystems. And as it turns out, that's one of the crucial enablers to us actually being able to do this experiment at all, is to be able to have people connect using their mobile device and use the software without us having to set up any additional equipment or having to rely on laptops, which I'll go into later on. Okay, and just a little pitch for Po's paper. So we have in fact done a bit of methodological research based on MobLab's data in the past. And so Po et al., including Colin Kammerer, Stephanie Wong, and Joseph from NTU, they've got this paper out that looks at basically replicating classic experiments using what's available on the MobLab platform using classroom experiment data from our users across the world. And so this is currently available on SSRN, but is also a revised version submitted right now at Nature Human Behavior. Okay, so the story of how we actually got into this. So basically, I learned from our CEO, Walter, one day that there is the summer camp happening at Xiamen University. And this is an annual summer camp in which these third-year, mostly economics majors come from all over great universities in China to learn about Xiamen University's graduate school programs. And so basically, they've got a week of activities, and we had this opportunity to do a 2-hour, sort of lecture on the topic of the history of experimental economics and run some experiments. And we basically had 45 days from learning of this opportunity to actually implementing, designing, and deploying the experiment. And so time was a little bit short, and that led to basically us not being able to optimize everywhere. So we try to pulling everything into sort of satisficing and optimizing conditions, and satisfying what was minimally required and optimizing where we could. But one of the areas that hope to elicit some feedback from the crowd is also in terms of what we were able to do in order to make this experiment in terms of the design and the controls as optimal as possible, given the situation. Is this still a sort of a worthy setting for conducting experiments or replications or whatnot? So it's something to keep in mind as we go through this. Okay, so our objectives were fairly simple. First of all, we wanted to explore just the viability of actually running a money incentivized experiment at this scale, not inside a laboratory, because again, there's no laboratory that's going to fit this with the subjects in cubicles or something like that. It's just going to be an open auditorium. So seeing what kind of problems and challenges arise from that and dealing with that. And also to test large versus small group effects, so being able to subdivide the subjects into big groups of, let's say, 100 subjects and small groups of 10 subjects, and then comparing the effects from running the games. And then also studying some gender effects based on the competition scenario from Nearly and Westerland 2007, because we actually had a version of this game ready to go on the platform from a previous research collaboration with Yanchen at Michigan. So looked like an opportunity to run that as well. And finally, just comparison results for well-studied classic games. Okay, and so we had 45 days, or in my case, mostly many sleepless nights because of the time difference in preparation, to basically, first of all, deploy the entire platform in China. So we operate on AWS servers in the US for our main product, but in order to run this with sufficiently low latency and sufficient reliability, we actually had to move the platform into China. And we were in the process of doing that, but actually hadn't finished before we knew that we needed to do this experiment. And then we had to update all the games to sort of work on this customized version of the platform. Re-release all of our mobile apps in the App Store because, for something like iOS or the iPhone users, there's no way to get them to install custom software, as a one-off, right, for each of these users. You actually have to publish the software in the App Store, make it globally available, and then they could go ahead and use it. So make all of that compatible, test everything as best as we could. But as you'll find out, there's a lot of things that, for a 600-person scale experiment, you just can't test. So you just try to do what you can to hope for the best. And then finally, design the experiment, which we did in close collaboration with John Duffy. Register all the subjects, run the session, and then also pay and debrief all 600 of them electronically. Okay, so before the session, what we did was we had all the subjects basically like 2 or 3 days before install our mobile apps, register everyone to get on. This is exactly the same process as any of our student users would actually do. And then so after they did that, we had them complete this welcome plus demographic survey outside of class. So oftentimes I think when we run experiments in the lab, you have these surveys, whether for risk preferences or demographic characteristics after the experiment, but for the sake of time, because time is so limited in the lecture, and also because of what the school administration wanted us to do, they wanted us to do something more active. Actually, during the experiment, we had to move all of this outside. But that gave us a chance to make sure, essentially, that all the students were actually on the platform and that it was actually working before we actually got into the classroom and run the games. Okay, and so at this point, we had close to 700 students actually on the platform, but you'll see that with experiments of this size, when everybody's participating, you're definitely going to take some losses in terms of how many people successfully complete the task once you actually get into it. Okay, so the day actually of the experiment, we basically kind of pseudo-randomly divided people into these different sections. So just kind of because based on randomly where they were being seated, we had these A group and B group sections in the auditorium. And based on that, we had people join different games in our platform, and that way we could split them into these groups of size 100 and size 10. And so what would happen is after you had these two pools of people, our platform could then automatically assign people in the two pools to games of group size 10 or games of group size 100. And so pretty much after we got through the intro, we would get through these games one by one by having Zhi go ahead and lecture on some instructions of how the game works, and then we would play the game, and then he would go back to presenting the instructions, and this would continue through the entire battery of games that we had.
But do they know that they are part of A or B?
Yeah, they would. Yeah. Okay, so for the actual game panel that we ran, we did beauty contest, a voter turnout, 2-candidate game, public good, linear, ultimatum bargaining, our version of a Holt and Laurie, which is just a sort of a graphical version of it, but it's essentially the same as the vanilla version. A centipede game, a trust game, and what we'll call the competition, which is again based on nearly a Westerland, but not exactly the same. This is an electronic. Everything was pretty standard. I don't know if there's anything in particular to point out here. I think we're good. Let's just go ahead and get into what it sort of looks like. So again, all of the games are actually on our platform. If you're interested in what these games look like with the exact sort of configurations that we have, feel free to just go on MobLab.com, and then you can, as an instructor, you can sign up for an account for free, and you can demo through and play through any of these games that we ran out of the experiment, basically. But to highlight one that is pretty interesting, this is the additional competition game. And so basically the structure goes as, first you play this game to get sort of acquainted with what the task is, and you play it piece rate. Then you go ahead and enter into a tournament. I believe in the original paper that tournament was against real people, but due to the constraints of what we were what we had available on our platform. We actually had the players play against what I'll call robotic players, but the robotic players, essentially their distribution of moves or their distribution of performance is drawn from real player performance data that we captured in the past, right? So it's like robots based on real people's play, essentially. Okay, and this is the task. Pretty much you just select two numbers that add up to 100 and you can submit. Because this was done on mobile, it was basically touch screen, so everybody had a phone out and then you can go ahead and use your two fingers to select the numbers and add them together. And so pretty much, piece rate, you just earn 1 point per correct problem, and then tournament, you're going to compare it against the distribution of past players' performances to see whether or not you won the tournament. And then after the first two rounds, you get to then have the choice. Do you want to do the piece rate, or do you want to do the tournament? Playing the tournament, if you win, it's potentially going to be more lucrative due to the payout structure than if you just play the piece rate. Okay, and then another example of a game, this is a centipede game. We guzzy it up for the students because they typically like something more visual, so this one's about passing a pumpkin, but the core gameplay is exactly the same. Okay, and this is just a quick look at what the experiment auditorium actually looked like. There's Walter, our CEO, and there's Professor Lee, and that's the students. So it was a big lecture hall, a ton of students. Okay, and quickly go through things. I don't think I have that much time left. So again, 673 participants had successfully completed the demographic survey, and so we have the data. Majority of them are either social sciences or business, with a few more in math, and then some other students. They basically come geographically from all over regions of China, although the closer they were to Extremity, the more likely it was that they lived in that region. Same with the originating school. Okay, and in terms of gender, it was significantly female-dominated, and also in terms of like one child or not, it was actually pretty evenly split. Mostly people like around 20 or 21 years old. So what you would expect with third-year university students. And this is just a quick summary of how the groups actually did in terms of completion. So I think you can see that Beauty Contest being the first game that we ran, there were some losses of setup in terms of just getting people to get into the game, join, and make sure everything was not crashing. But pretty much after we got to the second game, we were getting sort of maximal turnout of over 600 to 650 students completing the game for each round thereafter. So that was pretty cool. Okay, and to quickly go through some results. So in the beauty contest game, we find that players in the larger groups are going to get closer to the equilibrium over 3 rounds than the players who are just in the groups of 10. I don't know if this is hugely surprising, but I think it's a pretty good replication. In the voter turnout game, we found that average turnout actually decreases when the group size increases. And in the public goods game, we find that players in large groups tend to contribute more. And the two graphs on the right are actually graphs that we typically generate directly for the instructor. So the instructor is actually playing the public goods game. They actually have access to the two distributional graphs on the right to present results to their students in class. But the takeaway is kind of that the variance between group contributions is a lot lower for the 3 groups of 100 than for the 15 groups of 10 or so. So there's a lot more variance in terms of how the groups actually did overall. Okay, and for the Ultimatum game, this is based on the same type of analysis that Poe did for all of the other data that we have in our system for Ultimatum games played in classrooms. So again, you found that there are a lot of focal points at multiples of 10. You could estimate a discontinuous jump at 50-50. In fact, this is something really interesting that you might want to take a look at this paper if we ever get a chance. We actually collected response time in that paper, and there's actually a really interesting result with respect to how quickly subjects can make a decision with regards to the response time once you went from an unfair to a fair offer. So you can see a discontinuity in the response time as well. Okay, so our dice lottery risk aversion, we find less risk aversion than the actual whole lottery data, but it's broadly comparable. Centipede game, there are fewer steps in the last round. I mean, I think this is pretty much expect. Trust game, the average return rate is 76. So in this setup, the player 1 gets an endowment of 100, player 2 gets an endowment of 0, the multiplier is 3. In the competition game, okay, so we find that 26.8% of losers in stage 2 choose tournament, and 25.6% of winners in stage 2 do not choose tournament. So pretty much, winning or losing in stage 2 has, a huge influence on whether or not you would want to pick the game type that you're doing better. But then to break down in terms of gender differences, again, we might want to take this with a grain of salt because this game was played kind of late in the stack, and also, in terms of our distribution between genders, it's pretty skewed female heavy. We still have to think a lot more about, any kind of confounding effects when we do more significant data analysis. But at least roughly, what we find is that there were significant performances across all rounds between the male and female subjects in terms of their performance. We also found a statistically significant difference between male and female performance between round 1, which was the piece rate, and round 2, which was the first time we saw the tournament. And in terms of the effect of winning or losing the second round, so win 2 is telling whether the players won the first round, won the second round, or lost in the second round. We basically find that more male players would choose to enter the tournament conditional on the fact that they actually lost in round 2. So essentially, that males were still more likely to enter the tournament conditional on the fact that they lost in round 2 than the females were. Okay, I think I have 1 minute left. Sorry, I kind of breezed through that. I was just trying to put everything in. But here is some more pictures of the experiment environment. You can see basically we've got everybody on their phones playing the game, and I believe they were actually relatively attentive, and there was not like too much disruption, if you will, in terms of like players trying to interact with each other outside of just paying attention to the game scenario, even though they were kind of sitting together really closely in this crowded environment, which is good. Okay, and so a couple of methodological takeaways. So first of all, you can make these large auditorium-sized experiments work, but obviously you're going to get control in the degree between the spectrum of a really controlled laboratory experiment and something like a field experiment or an online experiment. Okay, so you're not going to get the perfect level of control that you might in a traditional lab experiment, but it's still better than just letting people sort of play this online remotely, I would argue. And also, in terms of making it a success, obviously planning ahead and testing on site as much as possible, but also having some people with technical know-how be able to back you up. So what I didn't tell you was that actually, T-minus 10 seconds or whatever before the first game was due to start, we actually had a bunch of people try to log in at the same time. And we found out that our login servers couldn't handle the load of 600 people trying to connect. And so immediately I was just calling up our engineer Raymond and had him go directly onto our back end, spin up a bunch of extra servers, and then we were able to get people in after a few minutes. So without somebody with that level of technical know-how, we definitely would have not been able to actually run the experiment. And so I think in general, this type of experiment, given the amount of control or sort of the difficulties in making it precise, it's especially good for replications, but maybe if you wanted to do some kind of novel experiment, you want to try it at lab scale with more controls first, and then you can sort of expand it to an environment with a larger number of subjects, but less control. And one final takeaway is that I think doing large-scale experiments, mobile-friendly software is actually quite critical, because, for example, even if we had somebody, even if we had all the students use laptops, for example, supplied by the school network probably could have never handled, the Wi-Fi network, handled 600 students or 600 Wi-Fi clients trying to connect at once. So we actually had all the students, because they were using cell phones, connect to mobile network, which is much more robust to a large number of simultaneous users. It's not that there was a huge bandwidth requirement from our games, but it's just the sheer number of people trying to connect to networks at the same time. It's much more feasible to do it with mobile devices and smartphones that connect to cellular networks than to actually do it with Wi-Fi. Okay, well, I hope that was entertaining, if not informative or useful, but any questions about the experiment or the data?
I have a question about, suppose you were doing something a little bit more interactive, like trading in an n-person market. What is the value of n that you could do feasibly?
So based on what our double auction can handle, at least in terms of like raw backend testing, we can go up from 600 to 1,000 to even more comfortably.
So you could have had every single student trading in a double auction, you think?
Well, potentially, when you want to scale up an experiment at this scale, both in terms of your backend, how that is handling all the data that's being generated in that market, as well as the front end of how you're delivering the UI, all of that matters. Like I would say that we could comfortably handle that in the backend, no problem right now. But depending on how fast your smartphone is, and for example, how much, like let's say you were trying to draw the market data in a graph for the user to see. Like if you were trying to draw too many points and you were doing it in an inefficient way in terms of your front-end software, then somebody's smartphone itself could actually be bogged down, right? And they would have a bad or poor experience just based on lag, purely on the front end rather than the back end. So there's a lot of different components that need to be optimized in order to scale up. I would say that currently, again, our back end totally handle that no problem, but the front end we do need to take a look at and maybe do some optimizations. But given what you know about what is possible on smartphones in terms of gaming, I think it's not a stretch to imagine that something like these 2D games that we as economists typically run, right, for a lot of classic scenarios, you should be able to scale them up. It's just a matter of the technical know-how, right, and doing it right.
Thanks very much.
All right, thanks.